Hello, everyone. So, who's the smug little guy on the right, I hear you ask? Well, that's my son, Adam. And for a 24-hour period last June when we were in London, he was the richest person in our family. Why? Well, Visa had a European-wide system outage. That meant Adam, with a sum total of £45 sterling in his little Velcro wallet, became our chief holiday financier. So for a minute I panicked as I tried to figure out how we were going to pay for travel, food and accommodation in a foreign country when we didn't have any access to our bank accounts. And I became utterly kind of aware of how dependent we've become on our software systems. And I became utterly, I realized completely that when things go wrong, it makes you feel so vulnerable as a user. It really, really, really does. And then I began to think about the teams of engineers scrambling in the background trying to solve this problem. And I could almost feel that sense of pressure, that sense of stress, that sense of almost responsibility and shame. And I could almost hear the blame-laden questions coming from senior management. How could this have happened? Why didn't we test for this? Nobody wants to be that Visa engineer, and nobody wants to have their holidays ruined either, by the way. So software, as it says here, has eaten the world. There are real costs to software failure, financial and human, for both users and the people creating and running our software systems. So the big question becomes for us then is how can we deliver value to our customers quickly, reliably and sustainably when we're working in an increasingly complex world where everything is connected, change is continuous, and failure can be catastrophic. If you're anything like us where I work, you've got dozens, if not hundreds, of microservices that are continuously changing and evolving, deployed into cloud platforms that are completely unreliable, and you're integrating against third-party services that can change at a moment's notice. In the past, we were, we had these kind of monolithic, all-encompassing Big Bang releases. And when things went wrong, they went very, very, very wrong, and everyone knew about it. But these days, we have a constant stream of releases going out. And our systems are in a constant kind of partial state of failure, but nobody's quite aware of it. So this scary new world presents a whole new set of challenges and a whole new set of risks. And as a consequence, we need a new approach for this. Oh, sugar. So I believe that we have to unlearn our old ideas about the way we develop, test, and operate our software systems. And I believe we have to stop thinking that we can anticipate the ways in which our software systems will behave. Tests are not reality. No matter how much testing we do before production, it's no guarantee that things will work in production. And with these complex distributed systems, failure, as I said, is inevitable. And the truth is that our journey, our job, it no longer ends when we deploy. Deployment is just the beginning, and it's only when we get our code into production that we actually start learning about how it's being used and how it will perform. So we need to rebalance our efforts, not just focusing on prevention of defects or detection, but we also have to focus on mitigation and recovery so that our teams can move quickly with justifiable confidence. And we have to start designing for testability and operability from the outset. And by doing that, it'll allow our teams to detect, isolate, and remediate problems quickly. So today I'm going to tell you my story about how I came to these conclusions and the journey our teams have taken to not just survive in this complex new world, but thrive. So I had an experience that completely changed the way I think about software development about 6-7 years ago. I just started working as a test automation engineer for a US hardware multinational company that decided to open a new software engineering department in Cork, where I'm from. And the first thing they decided to do was to get the entire engineering department to partake in, as part of our onboarding, in a regression release for a forthcoming, a regression testing cycle for a forthcoming release. So after 7 weeks, yes, 7 weeks of torturous regression testing by the entire engineering department, the release limped out the door. And one of the development engineers, a guy called Alex, who actually took over the role as software architect, came to me after enduring that torturous 7 weeks and asked me one simple but poignant question. How can we make this software easier to test? Oh, come on. Oh, sorry. So I went away and we talked about the various challenges we faced in testing this. And I came up with a solution that I now call the CODS testability model. Now, CODS is a mnemonic, and each one of the letters stands for a testability attribute that you should consider when designing your software systems. So the first letter is C, which stands for controllability. So controllability is the ability to identify and control the variables that influence system behavior in order to visit each important state. Next is observability, and observability is the ability to observe and understand everything important that's happening in the system. Next, decomposability, which is the ability to decompose the system into independently testable components. And lastly, simplicity, the ability to easily understand the system. So we went away and we implemented our new design in the Cork office based on the CODS model. And there was a steep learning curve initially, but after that learning curve we started to see some absolutely phenomenal results from this focus on testability. So for me, a well-tested system is both checked and explored. See Elizabeth Hendrickson's Explored book where she brought this to the fore. So from a confirmation perspective, or from a checking perspective, we want to confirm our beliefs, or the knowns. Does our software system do what we expect it to do? Can we confirm it does the things we expect? And next, we want to explore, we want to uncover those unexpected risks, or those unknowns. Are there problems we didn't anticipate, and that can only be found by actually interacting with the software itself? Oh, excuse me, jumped ahead. So by focusing on testability, we improve the automatability and the explorability of the product. By automatability, what I mean is our ability to automate those checks. And by explorability, I mean, well, I'll define it. It's a word I made up, a bit like Anne-Marie earlier. Explorability is the ability to quickly, cheaply, and safely learn in an unfamiliar situation by iteratively identifying, testing, and challenging our hypothesis. So exploration is a very human process. It requires us to use our initiative, our skill set, and our experience to refine our mental model of how our system works and behaves. So by focusing on explorability and making a product more explorable, we can accelerate the rate at which people can gain a deep understanding of how their system behaves and why. So, going back to my story, before we focused on testability, we were down here in the left and bottom quadrant. We had low testability. We had huge amounts of manual checking. We were spending huge amounts of time manually interacting with the software, and it was hugely time-consuming, hugely error-prone, and absolutely soul-destroying. And what time we had left, we were trying to maintain and debug flaky test automation. And as a result of this, we were doing very little exploratory testing. And lots of problems were going undetected as a result. By focusing on testability, we got high automatability. So we now had a really robust suite of automation, a broad, deep, robust suite of automation that provide really comprehensive feedback on thousands of attributes in seconds. And so we were getting almost immediate feedback on every change as it was pushed. And it was really, really great at detecting behavioral change, or those expected behavioral problems. And because we now had a really great suite of automation to give us feedback, it freed up our testers to do different types of testing. So it freed up our testers to explore the unknowns, to uncover those risks, and to do really deep exploratory testing. We now start to do completely different types of testing. We started doing resiliency, performance, security, and started finding different kinds of bugs that we'd never had a chance to see, to actually detect before. And as a result of both the high explorability and automatability, as I said, we had high testability, and we were able to detect different types of important bugs really, really, really quickly. So automatability provided fast, reliable, comprehensive feedback on every change, and it drove action. And what I meant by that is that when our automation failed, it was an invitation to explore, a bit like what Richard Bradshaw says. And our explorability provided skilled, curious, deep exploratory testing, which drove our understanding of the system itself. And that combination of great exploration and automation accelerated our feedback and ultimately minimized waste in achieving shippable quality, if that makes sense. So what did this focus on testability achieve in the company? So this approach that we championed was adopted across all 6 development teams in Cork, but then across all of the teams in the US as well. There was huge benefits in terms of the speed of delivery and the quality of the product. The release process went from 7 weeks of torturous regression testing down to a couple of days of exploratory testing by a couple of engineers. And most importantly, the teams were working at a sustainable pace and delivering value, and they were really happy with the work they were doing. But I guess the one profound learning I had from this experience was that significant quality improvements weren't driven by testing. They were driven by building relationships and influencing the right people at the right time to build quality in. There it goes. So this takes me to the next stage of my journey. So I started working with an early stage startup. I guess there was about 20 people in total, maybe 6, 7 engineers. And we were a business-to-business SaaS-based company that provided online fraud detection for online merchants. And we'd gotten some real traction in the market. And we were starting to attract some of the biggest online retailers in the world. And this was a whole new context with a whole new set of challenges again for me. So because our service was integrated against our customers' cart page, our platform had to be always available, hugely responsive, and scalable to fluctuating customer needs. So the first thing I did, of course, when I went in there was to build out a suite of test automation. But that test automation gave me no feedback on availability, responsiveness, or my ability to scale. So what I realized was that our risk actually lived in production, and we needed to test where our risk lived. So why was it in production? Well, we couldn't recreate the variety, volume, or complexity of production-like traffic in our test environments. So what I decided to do was repurpose my CODS model for operability to allow us to safely deploy and test in production. And to do this, again, as I said, I applied the CODS testability model. The first thing we looked at was controlling risk exposure. And in order to control the risk exposure, what we did was we used blue-green deploys to allow us to deploy very quickly and flip back if we saw any issues really quickly. Then we added observability for the system behavior. We added instrumentation to the code that allowed us to visualize our critical customer pain points. And we put monitors up all over the place. And during a release, the whole team would downwork and they would monitor the change as it went out. Next, we decomposed the releases. We decomposed the releases into single change sets so that when there was a problem, we knew exactly where the issue was being introduced from. And lastly, we simplified the release process. So releasing was a single button click and rollback was a single button click. And what this did was it accelerated our team's ability to deliver value to our customers without negative impact. And for me, it showed me the power of deliberate testing in production and how wonderful that can be when done well. So, as I said earlier, no matter how much testing you do in a pre-prod environment, there's no guarantee that it will work in production. So if you're not testing in production, then it's actually your users that are testing in production. Okay? So, So the biggest testing challenge I had when I was working at this startup was surviving Black Friday. So if anyone doesn't know, Black Friday is the biggest shopping day in the US, and because all our customers were online retailers, it was a huge challenge for us. And our old persistence layers was creaking. It wasn't going to survive Black Friday, so we had to replace our entire persistence layer, all the databases before Black Friday. So I went back to my bag of trick, my CODS model, and again, I decided to use CODS, and the first thing I did was to look at controlling our risk exposure. And I did it this time using feature toggles. So I added a feature toggle to allow us to control whether we were writing to the old persistence layer, the new persistence layer, or both at the same time. And I added another feature toggle, or we did, to control whether we were reading from the old persistence layer, the new persistence layer, or both at the same time. And from an observability perspective, what we did was we added instrumentation to the code that allowed us to compare the data that was being pulled back from the old and new persistence layer when we had our dual read enabled, and throw an exception whenever the data was different. So what we then did was we put the new persistence layer into production behind the feature toggle, so there was no customer impact. We enabled dual writes so that we scaled up production level writes to the new persistence layer. Again, customers couldn't see any of this. It had no impact to the customers to see how it scaled. And we identified problems and fixed them behind the feature toggle. When we had that sorted, we enabled dual read. And what that did was allowed us to read from both old and new persistence layer, compare the data, and alert on throw an exception when there was a difference between the data. And again, we monitored that with production traffic for a number of weeks, fixed the issues, and ultimately what we then did after a couple of weeks of monitoring was toggled on our new persistence layer, toggled off the old one, as simple as that. So we managed to get this out and survive Black Friday, and we sold the company a matter of weeks later for 44 million. I didn't get any of it. But what this really shows is that you can take a hugely risky, hugely potentially stressful situation and turn it into a stress-free routine affair by simply thinking through how you're going to manage risk and using the CODS operability model I was talking about there. So here's an overview and some examples of some of the other approaches I've taken to control risk exposure. So we've used blue-green deploys, we've used feature toggles, canary releases, A/B testing. To observe system behavior, we've used instrumentation, logging, monitoring, alerts, dashboards, synthetic tests, data analytics, tracing, and feature flags. From a decomposing deploys perspective, as I said, we deploy a single chain set per deploy. And then over here in simplify deploys, we have single click of a button to deploy and rollback, but also automatic rollback on error spikes, which is pretty cool if you can do it. So one thing as well that I suggest you do as well is test for operability. You have to test the infrastructure that supports your software system, because you need to know that it will work when you need it most, which is when things go wrong. So we literally test our infrastructure as well, not just the production code. And we had two interesting things that we found. So we ran some load tests with malformed JSON that showed us that that brought down our entire Sentry. That brought down Sentry, which is an exception tracking tool. Another time we were testing our infrastructure, we brought down Zipkin, which is a distributed tracing tool, and we uncovered a coupling or dependency between Zipkin and our actual production code that meant that if Zipkin was down, our software systems became unresponsive. So it's important to test this stuff, it can catch you out. So that brings me up to my current job, so quality coach at Populo. So all this work on testability and observability kind of taught me that there's a lot more to be gained from building quality in than simply testing. So I work now across all the development teams in Populo, and I work as a quality coach. I work with them to identify their quality goals and help them in achieving those goals. And one of the things that I've learned from coaching over the years, and the pattern I've seen emerge, is that observability is the most important thing to work on first when you're coaching teams. Because observability allows you to get an understanding of reality. It allows your teams to understand how healthy their system currently is. It allows them to understand how their system actually behaves as opposed to how they imagine it behaves. And it allows them to identify where they need to focus their efforts. So if you want to start out in this observability journey, there's some simple questions you can ask. How would you know if your system wasn't healthy? How would you know if your users were having a bad experience? In the event there was a problem, how would you isolate the cause? And these are simple questions, but it's a great way to get people thinking about this. It's a simple technique, but it gets teams thinking about what are the important quality aspects in their system? What are the health indicators? And it starts getting them to identify and add health indicators. And by looking at this kind of data, we start to get an understanding of what normal looks like in our system and what abnormal looks like. So for a well-observed system, I believe the system has to be both checked and explored. We check known failure modes, our indicators that we know are symptoms of our customer pain. And we explore for the unexpected behavior and unusual patterns in the production data. So by focusing on observability, we improve the monitorability and explorability of our product. So early days in Popular, we were down the bottom left-hand quadrant again. We had really noisy, unreliable alerts, and when they went off, people rarely actually responded to them because there's thousands of them. There was just too many. And what happened then as a result was customer impacting issues were actually getting reported by our customers. We weren't getting ahead of them and finding them first. And even when we did detect issues, it took us an age to actually isolate what the root cause of the problem was. So by focusing on observability, we improved the monitorability. So we created a really small set of reliable alerts that were based on symptoms and not on, we weren't trying to alert for cause. We found the symptoms that represented customer pain and alerted on them, and they were actionable. And we also started exploring the production data deeply. We started getting a real understanding for our system, what it looked like when it was performing well and what it looked like when it wasn't performing well. And in the event of issues, we were able to slice and dice our data to isolate the root cause of problems really, really, really quickly. And what that gave us was an ability to quickly detect and isolate problems, which was really, really powerful. So again, monitorability provided fast reliability detection of system outages, but ultimately again drove actions. And explorability provided skilled, curious technical debugging and allowed us to get a deep understanding of our system. But again, the combination of monitoring and explorability accelerated recovery from problems. It minimized the time and effort in detecting and debugging issues. So there are obviously clear parallels between testability and observability. I'm hoping you've seen them at this stage. So in order to become a high-performance team that can both move at speed and with stability, we need to focus on high testability. Because high testability informs risks. It informs the problems that we can imagine. We can test for those problems easily. It reduces the likelihood of failure before we deploy, and allows us to move quickly with confidence. Whereas high operability allows us to deal with reality. It allows us to deal with real problems. And it minimizes the impact of failure when it does happen, which is inevitable in these complex distributed systems, as I said. And overall, the combination of high testability and high operability allows us to move quickly with justified confidence. So going back to this, our combination of testability and operability provides optimized flow. Testability drives throughput in that it reduces, I assume everyone is familiar with the Accelerate metrics at this stage. If you're not, I suggest you get the Accelerate book and look up the metrics. So testability drives throughput. So the metrics it influences are reduced lead time and increased deployment frequency. And operability drives stability. It reduces our change failure rate and our mean time to recovery. Oh, excuse me. And between testability and operability, we optimize our team's flow. We accelerate delivery and we minimize the total cost of quality. So how did we create a culture with a focus on designing for testability and operability? So we begin to build observability into our systems of work, as well as our software systems, so we could see how our system of work was working. We visualized, socialized, and optimized for the engineering experience. So I'll go through some examples of some of the kind of workshops and things I did with the teams to try and, as I said, visualize, socialize, and optimize for the engineer experience. So this one I call the team testing experience, and it's something that I run with the teams on a quarterly basis. We get the teams, the development teams into a room, and we go through 10 factors that influence the testability. And they rate each of them. We have a discussion, and then we identify actions to improve the testability of the product. So this is based on another model that I call the 10 P's of testability. It's a holistic testability model. I won't go through all 10 P's, or we'll be here for another half an hour. So the next thing I've done is I have a team quality indicator board, and essentially what this allows me to do is have both metrics and conversations with the teams on a daily basis, where I go around and talk about the quality of their feedback mechanisms. So I ask them 4 simple questions every day, and you're probably asking, why don't you just automate this? But the power of the conversation is hugely important to this method. I asked them, have you had any alerts in the last 24 hours? Have you had any build and deploy failures in the last 24 hours? Any end-to-end test failures and any rework? And by doing this, we engage in really interesting conversations, and there's gamification, all kinds of funny business that happens as a result of this, but it's a really great way of bubbling up problems, various kinds of problems that we have. I have another one called the Operability Learning Review. So every time there's a customer impacting issue, it goes through our Scrum of Scrums board, and it has to go through a learning review. So everyone involved goes into a room, and we create this safe environment where we encourage everyone to talk about their experience, and it's essentially to allow us to distill as much learning as possible from each customer impacting incident. So we talk about the experience during detection, in terms of understanding the impact of the issue, in terms of isolating the defect, fixing and retesting the defect, repairing the data that may have been damaged, or the relationships with the customers. What was the experience like minimizing the impact, and ultimately then what was the experience like in trying to prevent this getting into production in the first place. Really powerful way of kind of learning about the obstacles that teams face. Another exercise that we do is we use story mapping in our where I work, but we involve people from customer support, tech services, and all this in our story mapping exercise, and we map out customer impacting issues for any new features or products that we build in advance. So we talk through scenarios or incidents, and we ensure that we have stories in place that cover it, so that when we release things into production, they're supportable and that we can operate them. So to finish off, I'm going to suggest 2 very simple things. If you only take away these 2 things, that's fine. Visualize and socialize your problems. So give everyone in your team a voice. Give the UI UX people a voice, the ops people a voice, the developers a voice, the testers a voice. Talk about your problems together. Visualize those problems and understand them. And then the biggest thing that I want you to take away for this is to optimize for your engineering experience. Make it as easy as possible to build, test, and operate your software system. And if you do that, you will get high-performance teams as a second-order effect. Thank you very much.